Did you know that the CPU in your computer is often referred to as the brain of the system? But what does that really mean? How does it actually information and perform tasks? Today, we are diving deep into the world CPUs to uncover how they work behind the scenes. Understanding CPUs is not just for techies. It's for anyone curious about how their devices function and why they can be slow or fast. Let's get started on this journey, and I promise you'll look at your computer in a whole new way. First, let's define what a CPU is. CPU stands for Central Processing Unit. It's the component that carries out instructions from programs by performing basic arithmetic, logic, control, and input-output operations. But how does it actually do that? Let's break it down. Imagine the CPU as a busy chef in a kitchen. The chef receives orders, instructions, from customers, programs. The chef then prepares the ingredients, data, and cooks the meals, executes instructions. The process starts with instructions coming from the computer's memory. These instructions tell the CPU what to do, like adding numbers or moving data from one place to another. The CPU reads these instructions from a part of the memory called RAM, or random access memory. Think of RAM as the chef's workspace filled with ingredients and tools. It helps the chef work quickly. Once the CPU has the instructions, it fetches the necessary data from RAM. This step is like gathering ingredients for a recipe. Next, the CPU decodes the instructions. In our cooking analogy, this is when the chef figures out how to prepare the meal based on the order received. After decoding, the CPU executes the instruction. This is where the actual work happens, the cooking. The CPU uses its internal components to perform this task. This includes the arithmetic logic unit, or ALU, which handles all the calculations and logical comparisons. You can imagine the ALU as the chef's special cooking tools, like knives and pots, designed for specific tasks. There's also a control unit, which directs the entire CPU's operations. Think of it as the chef's sous chef, making sure everything gets done in the right order. The CPU works at lightning speed, often measured in gigahertz, GHz. 1 gigahertz means it can execute 1 billion instructions per second. To handle all these instructions efficiently, CPUs have multiple cores. A core is like having additional chefs in the kitchen. If one chef is busy, another can take on more orders, cooking multiple meals at once. Now, let's delve into how information flows within the CPU. Data travels between the CPU and RAM through something called the system bus. You can understand the bus as the delivery truck that carries ingredients and completed meals between the kitchen and dining area. But there's something else to consider: caches. Caches are small, fast memory locations within the CPU that store frequently used data. Imagine having a pantry right next to the chef, stocked with the most used ingredients. When the CPU needs something quickly, it checks the cache first, speeding up the process significantly. Now, let's also discuss clock speed. The clock speed of a CPU, measured in MHz or GHz, is like the ticking timer in our kitchen. The faster the timer ticks, the quicker the chef works. However, speed isn't everything. Having more cores can enhance performance even with a lower clock speed, like having more chefs in the kitchen working together. So now you might wonder, why do CPUs get hot? Well, as the CPU performs more tasks, it generates heat. This is why computers have fans and cooling systems to dissipate that heat. The efficiency of CPUs has come such a long way. From the first simple microprocessors in the 1970s to today's multi-core processors that can handle complex tasks easily, technology evolves. Even in your smartphone, there's a CPU working hard to manage everything from video calls to games. Finally, let's discuss what happens when you notice your computer slowing down. It can be due to several reasons: too many open applications, insufficient RAM, or even an outdated CPU. Think of it as a busy kitchen where too many orders are coming in at once, slowing down the service. By closing unused programs or upgrading your hardware, you can give your CPU a much-needed break and speed things up. So there you have it. Now you know how CPUs really work, from fetching instructions to executing tasks. It's a fascinating journey that happens at incredible speeds within your devices. If you enjoyed this video and learned something new, please hit the like button, share it with your friends, and let us know in the comments what surprised you the most about how CPUs work. Stay tuned for more tech breakdowns, and remember, every time you click a link, there's a busy CPU working hard for you.